Sure. Hi, Irene. Thanks. My name is Juan Torres Perez. I am a research scientist at the NASA Ames Research Center in California within the Earth Sciences Division. And I'm also one of the PI of another science activation project called Oceanos. And during this summer, I had the honor of working with Lucas Baez, originally from Puerto Rico. Lucas, even though he's at a very young age, he has quite an impressive resume already. Before working with the Neurodiversity Network, he was a volunteer at the Ecoexploratorio Science Museum in Puerto Rico for some time. He was also an advisor for the Puerto Rico Department of Health, the Youth Council, among many other things. And he already started his bachelor's degree in electrical engineering, which is one of his main passions. So I know that we have Lucas here with us. We have, I think he has his parents as well. And Lucas made a video about his project, which he called Helios. And Helios stands for Handheld Light Attenuation Instrument for Ocean Citizen Science. So take it away.
All right, so I have Lucas's video here. I'm going to go ahead and play it. It's quite the cinematic experience.
Hello. Before I start, I want to give a big thank you to N3 Internships for allowing me to do this research project. It has been an amazing 3 months of experience. Without further ado, I want to present to you what 3 months of research has led us to create. We dub it Project Helios. Project Helios is a low-cost water quality measuring device which enables us to make science more accessible to the civilians of our island. For instance, if we can give Project Helios to several scientists around the world, we could measure data from several lakes to measure their quality of water and amount of chlorophyll to enable us to solve bigger solutions. This isn't the end for Project Helios though, as Project Helios will continue on. So, to start, I want to pass it along to William to tell you a bit about Project Helios' beginning, as he was the man who selected the tools for this experiment. And then we, Juan and I, and Roy, added our own spin to it so that we can make it and push it to the next level. So now, here's to William.
Hi, my name is William Hernandez. I'm currently a researcher for the University of Puerto Rico Mayagüez. I'm working here at the Department of Marine Science in La Parguera, in southwest Puerto Rico. So based on the previous research that we did, we then selected these sensors. These are mobile sensors that are easily accessible and pretty cheap in terms of optical sensors. And here with these sensors we can measure not only temperature but also light. And we use these sensors, is already available, and it has a Bluetooth connectivity that we can easily connect to smartphones. So other users, necessarily non-technical users, can connect to these sensors and collect information about water quality. And from these sensors, we develop a setup that we can then deploy as a buoy to collect water quality measurements all around the island of Puerto Rico.
My name is Roy Armstrong. I'm a professor at the Department of Marine Sciences of the University of Puerto Rico. The goal of this project is to develop low-cost instrumentation, actually to modify existing commercially available inexpensive sensors, such as the ones that we have here, so that they can measure specific wavelengths of light and using inexpensive interference of filters. This way, we can select two wavelengths that are used in chlorophyll algorithms by NASA satellites and can be used then to estimate the concentration of chlorophyll in the water. This way, we can use two of these sensors combined to estimate the concentration of chlorophyll, whereas if you use an expensive pherometer, such as the one that you see on the right, then it's very costly, so it's out of the reach of citizen scientists and most people. And the other goal of the project is that if the data is sufficiently robust using low-cost sensors, then we can distribute them among citizen engineers and scientists that then have more validation points for satellite data of ocean cover.
I want to thank Roy and William's part in this experiment. They've been such an amazing help to both Juan and I in this experiment. Now, I want to talk about how we decided to validate this concept of Project Helios. What we decided to do was take 5 hobos, and we decided to modify 2 of them, placing them with a cyan and blue filter respectively. We experimented with different concentrations of chlorophyll by adding a chlorophyll solution inside of the water in which we tested. And we detect to see if the change in brightness is apparent, because the more chlorophyll there is inside of water, the dimmer it's going to be at the bottom. When we took the hobos out of the water, we decided to analyze the data immediately. And what we found was that there was a difference in brightness. We found that all of them had that exact stir-like effect, stir-like graph inside, which we expected from those hobos, which is an amazing sight to see because it means that all of our research was perfect. As for the ones with the filters, we can take it one step further. We can go out of our way to measure how much chlorophyll is in the water by taking the ratio of the cyan values and the blue filter values, which allows us to do a simple calculation to then give us lines. So now I'm going to go in VoiceOver to explain to you these graphs in detail and all the data that we have obtained with this experiment.
As stated, I will show the results we have gathered with this experiment. First, I want to address the units we use. We use the unit lux to measure the brightness as the table of values for the hobos with the filters. Now, after that, we take the data from the hobos data, which takes data every second. Then we take the said data to form a preliminary raw graph, which looks like the one located in the top right corner of the page. Then we take the 150 brightest values as we concluded are the most reliable and calculated the average value to then make a processed graph located in the bottom left corner of the screen to show what it looks like. Finally, we take the average values of the blue and cyan filter hobos and divide the blue values to the cyan ones, giving us the measurement of chlorophyll in the water, which we can graph into a standard deviation graph as shown in the bottom right corner of the screen, which we can later use the power of Excel to obtain the equation shown and the R2 values. As shown, all the data lines up with what we expected. Ergo, this experiment, or calibration as we like to call it, was proven to be successful and compared to our experimental value of the EXO instrument.
Having looked at all of the data that we have gathered, we have proven beyond the shadow of a doubt with this sample size, or this calibration as we like to call it, that this experiment has not only been a success, it exceeded our expectations. But now, I want to take a little turn and talk about the future of where Project Oceanos is heading. To do that, I'm going to transport all of you to the beautiful state of California for my mentor to speak, Dr. Juan Torres. Take it away.
Lucas Prototype is the first of a series of low-cost, do-it-yourself water quality analysis instruments that will be built by Oceanos interns during the course of 3 years. But also Lucas invented a prototype for a low-cost, really low-cost spectrophotometer for measuring the absorption of light in different wavelengths. This low-cost spectrophotometer that Lucas also invented, we are expecting to test it against state-of-the-art lab instrumentation for water quality analysis as well over the course of the next 3 years with the Oceanos project.
To finalize this presentation, I want to give special thank you to all the people who have helped us throughout this experiment. I want to give a special, massive thank you to Dr. Juan Torres, who made this opportunity possible, for giving me the incentive and motivation to keep going, even though I was stressed throughout my beginning of college. I want to thank Roy and William for their part in this too, as they were the ones who benefited us with knowledge that we simply did not have at the time. I also want to thank my parents for taking trips and allowing me to visit this amazing place that I can call home, even though I'm several miles away from it. Now, thousands of miles away because I moved recently to Florida. But in a speciality, I want to thank the N3 internship team for making this possible for me to discover this hidden gem of my island. And with that, I want to close this and thank you very much for your attention. Till next time.
Thanks, Lucas, for that presentation and a beautiful ocean view. Give a round of applause for him. And I know he shared in the chat a link to the video on YouTube if you want to watch it again. Does anyone have any questions for Lucas?
I just want to put in an editorial comment that it was just very exciting to be able to work with 2 other NASA SciEx PIs on 2 of the projects, Dr. C and Dr. Torres Perez. It's just wonderful that we were able to collaborate, and I think that's the kind of thing that NASA headquarters was hoping for all along, with some cohesion between projects.